Why wouldn't it be twice the velocity? It's half the mass.
And there's your problem, Gary. And there's your problem.
Why wouldn't it be twice the velocity? It's half the mass.
JPG Rachi, if that's the right way to pronounce your name, I don't know, sorry. JPG Rachi has been urging us to try and find the logjam in Gary's understanding. If we think he's misunderstanding something, where is that logjam? There might be more than one. But here is one very, very, very significant one, I think.
Why wouldn't it be twice the velocity? It's half the mass.
Possibly the main one. Possibly not, though. Anyway, but here's one of the logjams, certainly worth very, very close attention and worth trying to hammer home to Gary.
Why wouldn't it be twice the velocity? It's half the mass.
I just have this doubt, though, that it really is a genuine logjam, and that in this particular case, the clip I'm going to show you in a second, I have a suspicion that what he's doing here is he knows that there isn't any problem with the lever in my original experiment, and that the lever is the cause of the light object going twice the velocity. Nothing to do with it being half the mass.
Why wouldn't it be twice the velocity? It's half the mass.
Nothing to do with it being half the mass, because I also show you in the clip coming up any minute now that you can put any weight on the lever. I put 2 kilograms on one part of the lever. So Gary, your claim is absolute nonsense. I put 2 kilograms on one part of the lever, and like your auntie's further down the lever, and the massive weight, the 2 kilogram one or whatever, goes much faster because of where it's placed on the lever. It's got to be twice the speed, Gary. It's got to be twice the velocity because it covers twice as much ground in the same space of time as that does. So Gary, your claim is absolute nonsense. But Gary here, in the first clip that's coming up, Gary here is trying to pretend, for the sake of his audience, this is where I honestly feel he's being deceptive, deliberately, just for the sake of his audience, because they won't know the difference. He's pretending for their sakes that the reason the red object operated by the lever is going twice the speed is because it's half the mass. So then he can point at me and say, you stupid person, you can say here that it's going twice the velocity, but further on in the video, in the Gary's cheat part, he's saying, no, it's not going anywhere near twice the velocity. Moron. But they're two totally different situations. The first one, operated by the lever, it's going twice the velocity because it's been operated by a lever. Well, you can see that it rolled that one faster because it moved twice the distance in the same amount of time. Now let's swap them over. Put the heavy one there and the light one at A. See, the heavy one went faster. In other words, Gary, the mass of the object has got nothing to do with how fast it goes off a lever. The mass of the object has got nothing to do with how fast it goes off a lever. The mass of the object has got nothing to do with how fast it goes off a lever. It's the one that's projected off that at twice the speed. It's got to be twice the speed, Gary. It's got to be twice the velocity because it covers twice as much ground in the same space of time as that does. So, Gary, your claim is absolute nonsense. And the latter example, in the Gary's cheat example, it's being launched by a spring, and you're swapping a half mass for a full mass object. And Gary is wrongly claiming that it should go twice the speed just because it's half mass. Just because it's half mass. There's the logjam, Mr. JPG. There's the logjam. Gary either thinking that happens or being willing to pretend that he thinks that happens. It's very hard to tell what's going on in his brain, why he would pretend such a thing. Anyway, coming up. Well, you can see that it rolled that one faster because it moved twice the distance in the same amount of time. Now let's swap them over. Put the heavy one there and the light one at A. See, the heavy one went faster. In other words, Gary, the mass of the object has got nothing to do with how fast it goes off a lever. Moron, are you listening, Gary? It doesn't fucking matter how heavy they are. They will still move at those rates. So I can put a heavy object there and a light object there, and the light object will go twice the speed of the heavy object, no matter how much force I apply there within reason. See, that goes faster. Put that there to try and stop it rolling off the edge. But the same happens if I put the heavy object there and the light object here. A little bit too aggressive, I didn't mean to do that. Try to have a lighter touch. See, the heavy object, The heavy object went faster, didn't it, Gary? The heavy object went faster. Put the light object there again. A bit too aggressive again. You can see now the light object goes faster. 3.144 kilos. And that one, can't read what that says. But anyway, obviously, a lot less. Let's try the heavy object at A and the light object at B. This bar is a bit flexible, so it's not ideal, but well, you can see that it rolled that one faster because it moved twice the distance in the same amount of time. Now let's swap them over. Put the heavy one there and the light one at A. See, the heavy one went faster. In other words, Gary, the mass of the object has got nothing to do with how fast it goes off a lever. It's the one that's projected off that at twice the speed. It's got to be twice the speed, Gary. It's got to be twice the velocity because it covers twice as much ground in the same space of time as that does. So, Gary, your claim is absolute nonsense.
The following clip will make more sense to you if you bear in mind that the previous run with the trolley loaded with double the weight, so it's not just 2 kilograms, it's 4 kilograms with all this weight inside it, ran the measured distance of 413 millimeters at 1030 milliseconds. Okay, 1030 milliseconds. Average measured over about 30 runs with very little variation really, just a few milliseconds here and there. Okay, so bear in mind that that's the standard speed of the 4 kilogram run with this particular force behind it. Now we're not changing the force behind it in the next clip. We're using the same force. All we're doing is taking out this weight, so we've halved the weight, so it really is then back down to 2 kilograms. Now watch the meters. According to Gary, it should halve from 1030 to 515 milliseconds. Does that happen? No, it doesn't. Bit of a giveaway. I spoilt it then, didn't I? Should have kept you hanging on, shouldn't I? Made it exciting. Yeah, I wish. So now it's just 2 kilograms total. Now the theory is it's supposed to go 1.4 times faster. RTZ. So 793. Oh, by the way, I should point out that this is where Gary predicts that it goes double the speed, isn't it? Because Gary's cheating experiment, Gary is basing his assumptions on the idea, the false idea, that when we halve the mass, from 4 kilograms in this case to 2, according to him, it's supposed to double speed, isn't it? Well, no, it's not doing that at all. At best, it's supposed to do 1.4 times faster, and I suppose that's under ideal conditions. But like I said, in the test I did at the end of that video, my last video, the one labelled Gary's Cheat, you could see that the red one went barely any faster than the other one.
Double the weight.
And Gary is wrongly claiming that it should go twice the speed just because it's half mass. Just because it's half mass. There's the logjam, Mr. JPG. There's the logjam. Gary either thinking that happens or being willing to pretend that he thinks that happens.
Why wouldn't it be twice the velocity? It's half the mass.
And there's your problem, Gary. And there's your problem.
Why wouldn't it be twice the velocity? It's half the mass.
If you are not lying and you really have just made this massive blunder, this is what you need to focus your attention on. Take a day or two off if you need to. Think about it. Maybe I should ease back on the criticism, because if there's any chance that you are making a genuine mistake here and that you're not actually lying, I would like to then give you the space to actually think, oh yeah, to correct yourself and let no more be said about it. You know, not to keep hammering you at it and not to embarrass you any further. If you were willing to sort of face the music and say, oh God, yeah, what a fucking massive clanger, because that's what you're doing, Gary. If what you just said is what you really truly believe, hand on heart and all that. Right, it's 8:30 in the morning. I've not been in bed yet. I need to get some kip. So I wanted to upload this today, but I'm not going to get a chance. Such is life. Onward and upwards. Onwards and upwards.
And here's just a quick sample of what's coming up in the next video. When I can find the bloody thing to upload, I've lost it. Can't be far away. When you got so many videos though, they get lost. All the titles all merge into one. And here's just a quick sample of what's coming up in the next video, where I do the same thing more perfectly, shall we say. Because the next video shows the same experiments being done where the pushing force is the spring, whereas the pushing force in this case was the weighted lever. That was pushing, and to change the force I attached a water bottle to the weighted end. But the original 4 kilogram pushing force was just the natural weight of this, yeah, because of the weight of the G clamp. Okay, and but then to increase it to double the velocity, I just trial and error added weight by attaching a water bottle to this, adding water to it until it went as close as I dared to get to double that speed. I mean, half that time. So from 1030 milliseconds to 515 milliseconds. That was the target. I stayed a little bit shy of it because I didn't want to get too close to it and accidentally go over it, or Gary claiming that I was going over it and guessing that it was going faster than double the velocity. So I kept shy of that. I'd rather err on the side of caution, so that Gary couldn't accuse me of cheating. He'll find something to accuse me of cheating. I don't know what. You know, like I say, he'll probably say you're wearing the wrong trousers, you're wearing the wrong shoes. You know, the music's all wrong. The women are showing the tits. So fucking what? Like, you, not like you've not seen tits before, is it? Anyway, onwards and upwards. Don't pretend you don't enjoy it, Gary. You fucking do. 1188 again. These are very close readings, some of these. It's quite a good little system we've got here, do you not think? I think it's not a bad system I've come up with. So 1188 again. So there's such a regularity about this now, isn't there? 1193. So now we just need to take out all that weight and put it back down to 2 kilograms. Okay. See, that was what was in it to make it heavy. 864. 828. 845. 844. 845. Right, oh, these are getting quite regular, aren't they? We've had that one before. 845. 845 again. 843. 843. 831. Isn't it? 827. 828. 1189 plus 1185 plus 1189 plus 1166 plus 1187 plus 1188 plus again 1188 equals 1186.2. Yeah, so I was right this time. So the first time I did the calculation, not quite right. I'm glad I've done it again though, make sure you get it right. So now we do the 2 kilogram one. Okay, 864 plus 828 plus 845 plus 844 845 again plus 845 again plus 831 plus 827 828 plus 810 plus 826 plus 847 plus 844 plus 846 plus 846 again plus 846 yet again plus. So 1186.2 divided by 839.478 isn't it? Equals Could that have been any closer? Wow. Could that have been any closer? Oh dear. Gary did, oh dear. That is, because it's supposed to be 1.414 and it's 1.413. Wow. Yeah. Oh, and just to be absolutely clear, and just to be absolutely clear, open and honest about things, just to be clear, the 4 kilogram runs, I removed 2 of the readings that were very spurious, that didn't fit in with the norm, so I had good reason to be suspicious. The first one I removed was the first one, which was significantly slower than all the others. None of the others even begin with 12, and that was because I'd left the trolley locked and loaded, ready to release for a minute or two while I talked to camera. But when I released it, it came out slower than all the others, which is in line with what I explained to PSEUDO the other day in one of the comments on his Getting Personal with Gary video. When I explained that I'd been watching that Smart Everyday programme show with Dustin Dunst, fantastic show. They were explaining that elastic bands and presumably springs as well lose some of their energy when the heat dissipates out of an elastic band that's been stretched. If you don't release it straight away, you lose some of the power of it, and they demonstrate that very, very vividly. Now I'm assuming it does seem to be the case when I've tested this that the same happens with springs, because since then I've not recorded it yet, but when you compress a spring and leave it locked and loaded for a minute or two and then release it, you get a slower time, about 20 milliseconds slower or something, than when you lock and load and release it straight away with minimal delay. You get a faster time that way, and that explains why most of the times after that all became more regular, because you get into a rhythm and some of they all start coming out exactly the same. There you can see 1187, 1188, 1188, 1188, 1193. But at first it was 1202. Then you start getting a bit of a rhythm up. Now the other one I removed, you can see there, the other spurious one was 1137. Now I've removed that one because the sensors had actually broken at that point. I didn't realize until the next run it was a failure. It didn't actually trigger, and therefore I had to just give it a little bit of a rub, because the contacts get a bit messed up sometimes with the trolley going over them. You have to give them a little bit of rub to make sure they're supposed to be momentary contacts where they go like that effectively, or sometimes like 2 wires short circuited by the metallic wheels. Doesn't make any difference. But so that reading, every reason to be suspicious there's something wrong with it, because it's miles off of all the other ones. So I got rid of that, and I got rid of that, and then I worked out the average by totting up all the others. I think that's 15 of them. I didn't have to remove any of those out of the 2 kilogram runs. If anybody wants to check my calculations, they're quite welcome to, but don't take out too much notice of what I've written here and there and everywhere. Some of it's my mistakes. That was the average. So, oh, too much detail. You can find out that later. Bore you shitless. You just want to go on and see some stuff, don't you? Hello. To save you listening. Start again. Hello. I know people don't like reading long. I'm so shit at this. I'm like a fish out of water. Try again. Hello, this is just a little bit of hastily put together information for Aero Soap Breeze, who posted a question to me. My answer was a bit long-winded, so you might not want to read it out. This is just me reading out my reply to Aero Soap Breeze, who posed a question to me today that I wanted to answer as thoroughly as I possibly could. I know people don't like reading long replies, so I'm reading it out for you, and at the end I'm going to tag on some experiments that'll give you a clue where we're going with this. It's not my final video of those experiments, it's just something to be going on with, okay, to keep your interest. Thank you for your patience. Yeah, it's just to give you an indication that I'm not just making this stuff up. I am actually measuring things down to a thousandth of a second as accurately as I possibly can. So if I release the trolley, stop the trolley, and that's what it's recorded, 1.259 for that trolley to pass between these 2 points. Doing everything as accurate as I possibly can, verifying the data, verifying velocities. RTZ, return to 0. 1, 2, does it measure? 1.243. RTZ again. Verifying masses, verifying that energy isn't being wasted in rotational energy, etc, etc, etc. Trying to do everything by the book, and soon I'll be doing it with air tracks as well, so I don't know what Gary will complain about them. He'll find something though, won't he? Maybe I'll be wearing the wrong trousers.
It's the wrong trousers, Gromit, and they've gone wrong.
Maybe I'm wearing the wrong clothes. Should have tried some different clothes, Gary. Might that help?
So, you like pushing women downstairs, do you? Well, try pushing me downstairs. See where that'll get you. I'll grab you by the balls and I'll drag you down with me.
Your clothes are too gay. The songs are all wrong.
Sing if you're glad to be gay.
The music's too gay. Your clothes are all wrong. The women have got too many clothes on. The women haven't got enough clothes on.
Some gay guy talking about sex, which is really weird anyway. Ooh, girl. Ooh, swimsuit.
Showing that they don't have much integrity.
Yeah. Ooh, girl. Ooh, swimsuit.
Yeah. Instead, they're just singing songs.
One more time.
Showing that they don't have much integrity.
This was really good. Yeah.
You can't get it right with Gary, can you? There's no pleasing some people, is there? He's wearing red shoes. Do you remember when Gary was criticising Lawrence Krauss for wearing red shoes? And Alicia Shepherd, fucking prick of the year.
One time we're gonna celebrate. Ay, 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 ay.
Alicia Shepherd, fucking prick of the year, starts making something out. Well, I don't want to do. Try and guess what she said. Guess the worst thing possible. And yeah, that's what she said. These people are morons. They really are. There are so many slates short of a roof. Seriously. See, this is the quality of Gary's. Is this the quality of Gary's support? The mental integrity. I mean, this is on the same level as that moron. Amanda making models of Gary's little tiny sofa and tiny shorts. I mean, who goes around making models of Gary's bottom? There are so many slates short of a roof. They must be getting soaking wet. It's criminal. Okay, so aerosate breeze. Okay, reply. Okay, so can you please explain why you claim the spring is a cheat exactly? I don't understand what you mean when saying that the spring can't necessarily accelerate the objects fairly. Why does the spring lack the ability to accelerate the half-weight object 2 times velocity if the energy in the spring is constant? Say if I have a setup such as this. Spring 1 loaded with initial energy will impart. Object transfers the energy after travelling some distance. Spring 2 collects energy for measurement. With the only variable being the object's weight, I don't understand why is that not considered fair. Now this is my reply, obviously. I've liked and hearted your comment. I'll probably finish shortly because I genuinely appreciate the opportunity to talk to you about this. Especially as you just volunteered to take on some experimental work for Gary. That's where I started out 4 years ago, volunteering to test out Gary's radar interference claims. Also, coincidentally, that was in relation to Gary's misunderstanding of another Waterloo in MIT experiment. But not wanting to get distracted from what you wanted to discuss, I may return to that if you have any interest on that particular topic too. So forgive me if I first rush through an answer and then add to it in as much detail as you might want a little later today, because I'm supposed to be somewhere else right now and I don't want to let a friend down. In fairness, I think I need to finally upload at least a clip or two of the new evidence, which is far clearer than Gary's basic claim about this 2 times velocity thing simply does not happen in reality. If you press me, I will let you see that. Perhaps I can let you see it privately. So very quickly, my reasoning is mainly based on practical demonstrations rather than me following any theories to the letter. Oh, and please remember that when I started out testing this, I honestly did not know whether Gary was correct or not. I was in some doubt. The work I did convinced me Gary was simply wrong, and that in all likelihood he knew he was wrong because he too had tested, but perhaps figured no one else had bothered. So he could make it into a bet that he was guaranteed to win, so long as he could convince everyone, including yourself by the sound of things, that the premise was correct, that merely halving the mass of an object necessarily made it go 2 times faster. It does not happen, it does not happen, it does not happen. I can show it not happening, measured down to thousandths of a second. Kinetic energy theory says it will go 1.414 times faster, but in practice, using low friction carts, and later I'll use air tracks, it always measures between 1.27 and 1.3 times faster. The discrepancy, presumably because my tests are not done in space, vacuum, there is air resistance. My trolley's cars are hardly aerodynamic. The fundamental problem is this: when the experiment has done far better, and yes, I do have such experiments done with low friction trolleys, cars, brand new aircraft grade springs, employing electronic timing to measure velocities to thousandths of a second, doing dozens of consecutive runs, continuously recorded to avoid further false allegations that I cherry-picked or cheated, documented in every way I could think of. Remembering that just like you, I am a skilled tradesman but not a scientist. So like you, I am capable of high quality work where funding and facilities are available to me, but I sometimes have to employ workarounds. I will soon have air tracks, incidentally. Sorry that sentence got out of control. I will start again. The fundamental problem is this: when the experiment has done far better, it is then measurable, accurately measurable, that Gary's fundamental claims, read the half mass going at 2 times velocity, is simply wrong. I'm sorry to anyone who believes otherwise, but accurately performed experiments show this without any doubt whatsoever. Gary's false claim is that the red object in the poor experiment I tagged on the end of my last video, Gary's cheat, was meant, according to kinetic energy theory, to go 2 times the velocity when launched by the same force, the same spring. The purpose of that experiment, which I could have explained better had I foreseen how confused everyone would be by absolutely everything Gary intentionally misdescribed, even the lever, was to show that Gary's claim of what kinetic energy theory says will happen to the red object leaving the launch spring simply does not happen, does not go 2 times velocity. Therefore, it cannot possibly be expected to compress the receiver spring with extra energy it does not have, never did have, except in Gary's intentional misdescription of what happens when we halve the mass of a launched object. He has recently said this is reality.
Reality says if I take a 10-ton train going 5 miles an hour and I smash it into a big giant spring, it's going to compress it a certain amount with its energy. And then when I replace it with a lighter train, okay, the train is going to leave at twice the velocity.
No, it isn't. 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 How many times do I have to say no, it isn't for you to accept, Gary? That no, it isn't. That you've made this up. You've got it wrong. Or you're lying. It's very hard to tell which. Are you stupid or a liar? One of the two. Either way, it's bad news, isn't it, for your fans? So no, this does not happen. Less than a week ago he said this. So it's not as if Gary is merely saying what their theory says. No, this is Gary's theory. Test 4. Gary's claim that merely halving the mass to be pushed by a spring pre-compressed by a full mass object will 1. Push it back at twice the velocity. I show that it actually pushes it back at the same velocity as the double mass original velocity. This experiment is subtly different to the previous one. My conclusion is drawn from 3 runs of the 2 kilogram empty trolley from the 3.25 inch measured compression depth. Although 3 inches would have been more typical, but to be on the safe side, I gave it the maximum compression 4 kilogram ever made at the slow velocity one. And those 3 runs were measured at 1122 milliseconds, 1126 milliseconds, and 1064 milliseconds. Comparable with the original velocity that compressed the spring in the first place, but with double mass. That was 1030 milliseconds average. So if anything, it is a little slower. You see, we're on 3 1/4. I'm a level with that. You ready? We've got 1.122. 1122. Okay. Same again. Compressed a bit more than I should be doing by rights. Return to 0. Let go. 1.126 again. I'll give it one more go, but let's be honest, Gary is talking utter bullshit again, isn't he? This is a half weight 2 kilogram trolley now. Return to 0. Go. 1064. So Gary talking utter bullshit as usual. Test, and it simply does not happen. I confess I am silly for not having yet uploaded a far better demonstration. My far better demonstrations that will convince anyone rational that Gary's basic claim of half mass objects going 2 times faster off the spring is simply 100% incorrect.
Stage 3. Testing Gary's claim that merely halving the mass doubles the velocity driven by the same force. Rejecting kinetic energy theory, which says it should be 1.414 times faster. Now, to do this, I repeated test 1, but with half mass. 2 kilogram unweighted trolley, still at force 1. Same as I previously did with 4 kilograms. Now, 30 runs resulted in 798 milliseconds average. The lowest was 789 and the highest was 815. Now, compare that to the 1030 milliseconds average with twice the mass. For Gary's claim to be true, we should have achieved 515 milliseconds. We're about 300 milliseconds short. And remember, this is all electronically timed, so it's unquestionable data. So the net result of that was that it went 1.3 times faster than with double mass. Now that is far closer to the kinetic energy theory, which says it should be 1.414 times faster, as explained clearly by the likes of William 1986. The small discrepancy, I'm sure, is due to me not doing the experiment in space. Plus, my trolley isn't exactly aerodynamic, nor is it a proper air track yet. Test 4. Gary's. So now it's just 2 kilograms total, isn't it? So, okay, just empty box. So now it's going to go faster. Now the theory is it's supposed to go 1.4 times faster. Let's see how well that holds up. Start a new column. I'll do it in red pen now to signify this is the lightweight. Right, so let's get going. RTZ. So 793. Oh, by the way, I should point out that this is where Gary predicts that it goes double the speed, isn't it? Because Gary's teaching experiment, Gary is basing his assumptions on the idea, the false idea, that when we halve the mass, from 4 kilograms in this case to 2, according to him, it's supposed to double speed, isn't it? Well, no, it's not doing that at all. At best, it's supposed to do 1.4 times faster, and I suppose that's under ideal conditions. But like I said, in the test I did at the end of that video, my last video, the one labelled Gary's Cheat, you could see that the red one went barely any faster than the other one. Subject first. Compare it to double the weight. I can't judge the results until I look at this in slow-mo. Now, we're going to find out now, aren't we? We're going to find out now very accurately how much faster it actually does go using the same force at half the mass. Gary says it should go double the speed. So we'll do the calculations after. Okay, I'll just do a run of 30 again to match the other ones and see how we go on. And I don't know the outcome yet. I genuinely don't. These hard drive wheels, hard drive platters make fantastic low friction wheels. These are my 2 kilogram weights that I put inside. So we get rid of that now. So now it's just 2 kilograms total, isn't it? So, okay, just empty box. So now it's going to go faster. Now the theory is it's supposed to go 1.4 times faster. Let's see how well that holds up. Start a new column. I'll do it in red pen now to signify this is the lightweight. Do you remember last time we used red rolls of coins to signify half weight, didn't I? Let's do the same now. Right, so let's get going. RTZ. So 793. Oh, by the way, hang on. I should point out that this is where Gary predicts that it goes double the speed, isn't it? Because Gary's teaching experiment, Gary is basing his assumptions on the idea, the false idea, that when we halve the mass, from 4 kilograms in this case to 2, according to him, it's supposed to double speed, isn't it? Well, no, it's not doing that at all.
At best it's supposed to do 1.4 times faster, and I suppose that's under ideal conditions. But like I said, in the test I did at the end of that video, my last video, the one labelled Gary's Cheat, you could see that the red one went barely any faster than the other one. Now, we're going to find out now, aren't we, quite accurately, well very accurately in fact. We're going to find out now very accurately how much faster it actually does go using the same force at half the mass. Because like I say, Gary says it should go double the speed. So we'll do the calculations after. Okay, I'll just do a run of 30 again to match the other ones and see how we go on. And I don't know the outcome yet, I genuinely don't. It should be fun. Off we go again. This is actually quite a good little experiment, isn't it, so far? Then after, I'll have to double the velocity and do the other test, but for now, same velocity. RTZ 794. RTZ 790. 791. 791. Well, these 79s seem quite common, don't they? 79s. 791. Return to 0. 792. Return to 0. 789. Return to 0. 790. You can tell the very low friction wheels, can't you, the way it bounces back and forth. 790. These are very regular figures, aren't they? No. 812. I'm getting a bad back here because I have to lean over. I'm in such a tight spot. And I can't move my feet because I'll knock the camera, as I did before. Right, okay. Change to 0. 791. I hope nobody's bored. Try being me if you're bored. If you don't feel sorry for yourself, feel sorry for me. No fucker does, particularly not Gary. He's got a mug to do all his experiments, and when he's proved wrong, he just ignores the results anyway. Says, fuck you, calls me an idiot and all sorts of horrible, vile things. And people support him. Why do people support him when I'm doing his work for him? I mean, if he's wrong, he's wrong. 790. I mean, if he's wrong, he needs to know, doesn't he? It's not my fault if he's wrong. People shouldn't be supporting somebody who isn't able to face reality, should they? They need to face reality as well. Return to 0. 790. These are very regular figures now, aren't they? 790. Oops. 804. I keep bouncing around everywhere, isn't it? Return to 0. 792. Return to 0. 792 again. This would be a lot quicker if I didn't have to keep writing everything down. But I'd rather write it down, just in case the recorder doesn't work. And I was proved right the next day because I lost all the data off one of my cameras halfway through the work. So it was helpful to be writing it down as I go. I just moved the camera and it just crashed. It says I've accidentally opened the disc cover. I've not, or not knowingly done, but that's it then. You lost everything you recorded. Sad, isn't it? Don't make Gary happy though to see me having a disaster, of course.
Oops, misfire. The wire's broke, so it doesn't trigger. It's triggering, but in all honesty, it's not too surprising it breaks. See how much longer it can keep going before I have to repair it properly. Return to 0. 810. Misfire. That's it. The last thing I feel like doing is maintaining the sensor. But if I have to, I have to. Return to 0. 811. Return to 0. 792. Return to 0. Misfire. 811. See if I can get through to the end of this. I'm nearly there now without repairing the sensors. Just needs a fresh piece of wire putting in really. Right, here we go again. 811, change to 0. 9, so 797, change to 0. 808, 808 state. after the TR 808 drum machine. Has to be a bit of a music in there, I suppose. 791, nearly there. Change to 0. 811. 792, change to 0. 811. 791, change to 0. 815. 815 from Waterloo Station. Calling that. Last one for the moment. Return to 0. 795. Stop. Right, let me check I've got 30 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so 30 got there then. Whew, I need a beer now. I know it doesn't look like hard work, but it's stretching and being squashed in a small space, plus it's late at night and one of them days, you know, when I'm not feeling well at all. Another one. You know when you feel like you're coming down with something but you're not sure? Not coronavirus, I don't think. Hope not, but you know, when you're struggling to breathe, you probably don't know that feeling. If you're young, you don't know. Your chest just really hurts all the time. I've knocked the camera. When did I knock the camera? Bollocks, when did I knock that camera? I'm still recording. Oh shit, 4 minutes left. I've not been doing it for 41 minutes, have I? Seriously? Wow. I'm going to have to pause and aren't I? I didn't realise I'd been recording that long. Shit, let's let me pause this camera. Sorry folks. Oh, I might as well use up the last 4 minutes. What can I do with the 4 minutes I've got there? So now I need to try and speed this up. Now my plan was to speed this up. Well, I've got to make it double the velocity answer, so I've got to make it double. What I'm going to do is add some extra weight, hooking this on, this extra weight of water. So it's going to be trial and error, adding this weight to the weighted lever that I'm using at the moment, to the weighted lever, until I get it so it's double the velocity of the first set of figures. Now, what we got? 1027, 1061, 1006, 1010, 1008, 1009, 988, that's the lowest, that's the only one I've had that speed. 1005, 1010, 1011, 1045, 1023, 1044, 1043, 1043, 1043, 1059, 1027, 1045, 1023, 1050, 1045, 1062, 1042, 1042, 1044, 1045, 1024, 1043, 1045. I'd say it's averaging somewhere around the 1030 mark really. About 1030. So if it's averaging really, I mean just rough, I'm doing this estimating in my head really for now, aren't I? So if it's roughly 1030 on the first run when that was full. So when that was 4 kilograms weight, then we halved the weight to 2 kilograms, but double the speed, don't we? Double the velocity. So instead of 1030, we then what? I've got to speed this up till it's to, what's half of 1030? 515. 515 is what we're going for, isn't it? Okay, 515.
Okay, stage 2. I've just did one test and there must be a dozen more. I'm throwing this information together a bit so they aren't in the right order. Should be obviously stage 1, 2, 3, 4, 5. It hasn't worked out that way. Oh well. Bollocks. Stage 2. That was for spring compression test 2, the light and fast, half mass, twice velocity 1. Now that resulted in 4.25 to 4.5 inches compression every time.
This is the first attempt now to do that. 2 kilograms at the velocity that I just measured over 35 test runs, almost twice the velocity.
And it's very, very, very important to remind Gary here that the reason it's going twice the velocity is nothing to do with it being half the mass now. We've made it half the mass and we've made it go twice the velocity by changing the force behind it. We could have quartered the mass, we could have quadrupled the mass and changed the force behind it to still make it go twice the velocity. The mass has got nothing to do with the reason it's going twice the velocity, Gary. Please don't misunderstand that, and if it's not a misunderstanding, it's just you deliberately misleading people, please stop stop doing that because it's ruining people's understanding of it. The reason it's going twice the velocity is because we're making it do so. We're changing the energy behind it. In my case, by trial and error, adding weight to the gravity-driven push system. We're adding force behind it to make it go twice the velocity. It has nothing whatsoever to do with the mass now being halved. Like I say, we could have the mass anything we choose it to be. I honestly don't know whether it's your misunderstanding about that or whether you've just deliberately decided I'm going to fuck this guy up completely and totally misdescribe everything. I'm a little bit.
Hello. So this is the first attempt now to do that 2 kilograms at the velocity that I just measured.
Pretend you've just seen me achieving that velocity. That's this column here. That's the third column along here. 2 kilograms at force 2. The first few of the trial and error ones where I hadn't got the velocity right yet. And then the next ones were about 30 or so. Oh, actually no, 35, 36. 36 runs. Anyway, it averaged at, see at the bottom written there in tiny writing. Yeah, it averaged at 528. I was aiming for 515 milliseconds. So the velocity I'm actually using, it's supposed to be double the velocity, but it's actually just a little bit less than twice the velocity. But that's in Gary's favour rather than mine, okay? I'd rather it would be in Gary's favour than mine, so he can't go around accusing me of cheating, making it higher velocity than it needs to be. Whew, it's hard work, this is. So much information to pull together, and this is just one of many. One of about 22 in total I last counted.
So this is the lightweight one. Roll it to the same position. You got an idea what was going to happen there, didn't you?
A lot of them a bit, throwaway, but some of them are really good.
1, 2, 3, 4. Just in case it isn't entirely clear. Just in case it isn't entirely clear what's going on here. So there's where the red reel has ended. So red reel has just hit that cushion. I'm in the way of it, unfortunately. But you can just see the top of the red reel there, just over my shoulder. Count. 1, 2, 3, 4. And that happens in the same time as the double mass reel reaches the halfway point. And this is the starting point that they both set out at. Count. 1, 2, 3, 4. So start, end, and halfway. Hopefully that's clear. And I'll repeat this 2 or 3 times. Very tricky holding it back because it's a lot of pressure. So I've got to let go and count. 1, 2, 3, 4. Ah!
Count. 1, 2, 3, 4. Ah!
Might not be quite bob on. I'll give it another go. Now you know what you're looking for. So that's the starting position. Push it up against the cushion. Go. 1, 2, 3, 4. Fine. It's alright when you're just watching it on a video. Round the fucker who's got to make this shit work. Here we go again. 1, 2, 3, 4. The heavy one was a bit past halfway, wasn't it, when that one hit the barrier? So yes, so that needs to go a bit faster, doesn't it, the light one? It's still not quite at velocity 2, is it? So at the moment, this heavy one's got slightly more momentum. This was only intended to be a rehearsal, but in the end I thought, well, it's not going to get any better if I keep repeating it over and over again. I'm not going to get the results any better, I don't think. Are you ready now? Are you ready now? That was a bit shit, wasn't it? When I do it with the fast one, that might be shit as well, I don't know, do I? Let me line them up again. I've got to be honest, I was expecting to be a bit better than that. 1, 2, 3. Not very impressive, is it? But then again, like I say, the other one might not be very impressive, so let's take the heavy one up. Can you see we've got a solid copper insert? Before I double its velocity, I'm just going to use the same pressure but on the lighter weight, where it's supposed to now go 1.4 times faster. Same energy, so it's being pushed with the same force. Go to. See, it's on a par, isn't it, with the other one, the heavy one. So it does look like same-ish energy as the previous one. It's going 1.4 times faster, pushed by the same weight. Half mass, 1.4 times faster, same kinetic energy, does the same damage by the looks of things, in keeping with the formula as I understand it. It is actually an interesting experiment. How many other people are even bothering to do this? Well, that was actually quite interesting, wasn't it? That was actually quite interesting, I must admit. And that was better than I expected. So it did do like 1, 2, 3, 4, a bit more besides, really, didn't it? And that wasn't even quite double the velocity, was it? I'm quite impressed that it actually worked. That was better than I was expecting. Gotta be honest, I'm quite pleased with that from a point of view of proving Gary shit for brains wrong. It's evidence against his crappy guesswork theory, isn't it? It's doing approximately twice as much damage, isn't it? Didn't get to the 6th one, but in fairness, it knocked the first 2 down, and the other one didn't knock any down at all, did it? Just moved them out of the way. Is this where Gary's going to start moaning like a schoolgirl, saying, it's just the same as the clay experiment? So I think it's sufficient to say that Gary needs to now cough up and pay for the experiment that he's been promising to pay for about 2 or 3 months. He said he was going to commission a proper experiment using properly engineered parts, and that whoever was wrong would fund it. Well, I think he should fund it now. I funded this one, I funded all the previous experiments, I funded all his radar experiments, I funded all his sound experiments, I funded all his polarization experiments, I funded all his slit experiments, I've even sent him slits that he's forgotten he's got. I think it's time Gary funded at least something. He promised $50 for someone who could show this kind of evidence. I've shown him this kind of evidence several times over now, and he still hasn't coughed up $50. I don't think he's ever going to cough up $50. He says he never welches on a deal. Well, I don't believe him. I think he will simply wriggle and wriggle, pretend the evidence isn't there, just to avoid paying to someone. Give the money to charity then. I don't particularly want Gary's money. I just don't want to see the guy getting off scot-free with lying what he intends to do. The only time he wants to put his money where his mouth is when he's got a rigged experiment. The one where he conveniently then forgets about the so-called excess friction of the heavy mass object. Suddenly the friction doesn't matter then, does it? Because he's a lying, cheating scoundrel, as I've said before, and will keep saying, because he is. Be very cautious of Gary. I wouldn't buy a raffle ticket from him. So this is the first attempt now to do that 2 kilograms at the velocity that I just measured over 35 test runs.
So I was aiming for 515 milliseconds, in other words, half of 1030 milliseconds. But to be on the safe side, to avoid giving unfair advantage to the faster object, I settled for 528 milliseconds average. So it was a little bit slower than it should have been, really. Yeah, so although this is supposed to be double the velocity, it was a little bit less than double the velocity. So the minimum was 507 milliseconds to 548 milliseconds over 30 runs. If you want to see all the readings, I will publish those too. Now, it's worth noting that only 3 of the 30 runs were slightly faster than the 515 millisecond target. Those were 507, 509 and 513 milliseconds.
So this is the first attempt now to do that 2 kilograms at the velocity that I just measured. Right, so testing spring compression using this device here. Aircraft grade springs. Maximum compression of 5.5 inches. That's as far as it can go. The spring is as compressed as it can go. Can't go any further. 0 compression. That line there, that edge. 2 kilograms going at twice the velocity, or almost twice the velocity, having measured it on that machine before. So now I've no idea. I'm a bit nervous about doing this, to be honest, because I've not done this yet, and I'm kind of, obviously I'm apprehensive, you know, because I don't want to look a fool. But if Gary turned out to be right, I've said this many times before, I don't know. If it just happened to be that Gary was right, that in itself would be absolutely remarkable. It would be remarkable, and I would be proud to upload a video proving Gary right if that happened to be the case. Now, if that isn't the case, it isn't my fault. And honestly, at this point in time, on my mother's life, I know my mum's dead anyway, but I still love her to bits. And the lives of anybody else I love, I've not tried this yet, so I don't know the results. I'll give it a few goes. I'm not going to do 35 goes, because it's hard work and it's late. The 35 goes was just to establish the velocity, try and get it to make sure it really was somewhere around double the velocity of the run with 4 kilograms, so that they had the same momentum. but I've weighted it in favour of possibly the 4 kilogram, having just maybe a smidgen more momentum, not enough to really make a difference to the experiment. I'm trying to make sure that it's not at all biased against Gary. I don't want it to be biased at all against Gary. I'd rather it was biased for Gary a little tiny bit, if anything, just so that there can't be any complaints after. You know how it works. Yeah, am I procrastinating here? Does it look like I'm prevaricating? I suppose I am a little bit, because I'm a little bit apprehensive about the results. Plus, it's always like that, isn't it? You know, when you're kind of excited but nervous as well. Anyway, get on with it, Steve. Now I've got this other camera just here again. I'll be recording a close-up view of that as best I can.
Well, so much for me bothering to record it on this camera. So much for me trying to record a close-up on this camera here. Because this camera crashed after about 40 minutes of good recording. Lots and lots of information on it. It crashed, didn't it? It said I'd opened a DVD cover. I hadn't, but it just ruined all the information I'd recorded. So I apologise that I don't have close-up views of this particular run, but them's the breaks. Life's tough, innit? Cheers, man. A little brew, because I'm fucking knackered. I deserve a beer. Crack one open. Fuck me.
So I've got to do a few runs first of all with 2 kilograms at twice the velocity. I wish I had a clue how far that went there.
I was relying on that camera that crashed, but as luck would have it, I used some other methods to check as well. A little bit of soft clay that would record where it hit it.
It's all over in a flash. So I'll put my finger on the 5-inch mark. No, it wasn't going to 5 inches, so I didn't feel that. Put it on the 4-inch mark. Yes, it went past 4 inches, yeah, I felt that.
That was me just trying to get a rough idea how far it was going, because you can't see it. But once I've got a rough idea where it is, I can put a very thin little bit of clay, then measure it very accurately. Yeah, that works out really well, actually. It's a very good idea, that. I congratulate myself on having a good idea.
I'll try 4.5 inches then. Yes, I felt it touch 4.5 inches to the 4.5 inch mark. I'll try 4 3/4. Ooh, what happened there? I think I must have lost. I've lost alignment, haven't I? Hang on a sec. Oh, something went a bit wrong there, didn't it? I'm aligning it by looking down the other end, how close it is. It needs to be a bit further across that way. A little bit. That's about it, I think. Oh, by the way, that dotted line there, I've written there, end of push. End of push. I'm pointing to that dotted line there because the absolute maximum that the pusher can still be actually physically touching the trolley is at that line there, and that's absolute maximum. So beyond that, it's then released, it's free. We're only relying on the momentum of the trolley itself. There's nothing else behind it anymore. So I've got this little bit further behind that, so we've got a little bit of clearance. In fact, I'll try a bit of clay. That's not a bad idea, is it? So I've put a bit of clay on the underside of this bar, so that then, the edge of this plunger, will leave a mark on that clay. It's trial and error. I might have put too much clay on. I'll just see how it goes. Might knock the clay off. Oh no, didn't touch the didn't touch the clay. I didn't put enough clay on. Okay, you live and learn, don't you? You live and learn. Try again. Ah! We have a recording of it. So I can tell you quite accurately now how far that went. Just let me get a ruler, or a rule as we were always told to call it at school. A king or queen or whatever is a ruler.
I keep talking about the camera zooming in, but of course you can't see it now because that camera crashed. So I'm sorry you can't see it, folks, but you'll have to trust me to a certain amount. Actually, further on this recording, I might show a close-up with this camera, the one I'm talking into now. I can't remember. We'll find out. I've not watched this recording for a while.
Just zoom in on this camera so you can see. So it went to 4 1/4 inches. 4 1/4 inches. So let's just do it again in case the... yeah, 4 1/4 inches exactly, I would say. Bob on. I think I better write that down on my score sheet, haven't I? 4.25 inches. Try again. I'm just thinking in case the clay restricted it at all. You know, the thickness of the clay. I don't know. Plus, we don't know whether that was one of the fast runs or slow runs. Remember, out of all the runs we did before, we had it as low as 507, which is just sneakily past what it should have been. Remember, we're aiming for 515 milliseconds, aren't we? We got it as low as 507, but only once. 509 once, 516. We have to ignore those early ones. Those runs when I was still experimenting with different weights, and I took some water out, didn't I? So those don't count. It was only from here, wasn't it? D36, was it? Okay, so the height was 546, was it? 548. Oh, give it another run or two. What did that read? Ooh, that's a lot further. Oh no, it's not. I'm looking at the wrong tape measure. It is further though. So this time, instead of 4 1/4, it was 4 1/2 less this time. Oops. So oh, if you knew what I was trying to work with in this house, the room, you'd understand why I get frustrated and angry that Gary does all this pontificating but never does any work at all. He just moans about other people's work. He's like one of those bad bosses, isn't he? Who orders his workers about and tells them off for not trying hard, you know, when all he does is sit, you know, with his feet on the desk all day. He's one of them, isn't he? He's like a failed capitalist. You can tell he always wanted to be a boss but didn't have the talent, didn't have the work ethic. Hell, he didn't even have the enough work ethic to do an experiment or two like this. In fact, he'd rather just talk for 5 months. Remember, for instance, beginning of December last year till now, we're nearly May, my birthday again. Been talking about it for nearly 5 months, and he'd rather just talk about it than do anything. Literally, he'd rather talk than do. He's all mouth and trousers. All talk, no action. All talk, no walk. Right, give it another go. Oops, it's not broken. Popped off the end of the tube. So where's this gone this time? Oh, it's the same as last time. Yes, it squashed it to the same. Can you see? Squashed it to the same as last time. See, gone to the 4 1/2 inch mark again. Well, after this, I've got to do the 4 kilo one at half the velocity, haven't I? So we've probably got enough information now already, haven't we, really? But I'll just do a couple more. I've not been writing these readings down, ever. Just let me write these down. That's 4.25. 4.5 is the one before this. This one was 4.5 as well. Do a few more. Bit less this time, a little bit less. It's in between the 4 3/8. Yeah, 4 3/8. Right. It is actually turning out to be quite an interesting experiment, isn't it? In the end, I must concede it's been worth doing the experiment again. So I suppose I can be grateful for people putting pressure on me to do it better, because you know they force you to do better work, don't they? Really. So long as they accept the results and don't start taking the piss forever. What have we got this time? Oh, a bit less this time. Just over 4 1/4. 4.3. 4.3. Same again. 4.3. Just over 4 1/4. Yeah, I think 4.3 again. Don't think I can argue with that. I'll line that up. I don't know if the camera can see. 4.3. Anyway. Release the hounds. That's 4 3/8 again, that is. Shit, shit, shit. I've lost. Bollocks, 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 bollocks. I've ruined it, I've ruined it, I've ruined it. Oh, you see that stupid message? I've accidentally touched the cover, and so I've ruined the test. Bollocks. That's really fucking sad. I've got the recordings though. I suppose if you can trust me on the recordings that I've made. It's just annoying though when you've recorded it. It's because I tried to move the camera and it's a shit cam. Fuck off, you wanky camera. Fucking bastard piece of shit. I think like Matador said, like I deserve better equipment. So I've lost all that recording, haven't I? Bastard. Bastard. Movie recording disabled. What the fuck you mean movie recording disabled? Fucking piece of shit. Oh, I'm pissed off now. I'm fucking pissed off now. Sorry folks, I'm sorry folks, I'm just fucking well pissed off now. Look, tell you what I'm gonna do, because I'm so fucking pissed off. I'm gonna just move on to the next stage. I wanna fucking throw this camera across the room. What I'm gonna do is, I'm gonna just rush ahead and just, you're gonna have to trust me a little bit. It's easy enough to do this again, isn't it? I don't know why I'm making such a fuss, but it's just frustrating when you thought you had it in the bag, you know what I mean? You bothered to make the recordings. But anyway, I'll just write this one down. 4, what does it say, 4 3/8, aren't it? Tell you what, so you know I'm not cheating, all I was trying to do anyway was give that camera a close-up view of, I'll use this camera, I'll move this camera. Oh man, you can't, because the fucking lead is about 2 inches long. I'll see how close I can get it though. I hope I don't fucking crash the camera, because that's the other thing that goes wrong with it. I'm still on. This is the thing that goes wrong with this bastard one. When you try and move the camera, it sometimes the camera just freezes and that's it. End of your fucking recording then. Right. Can the camera see that? If I move this closer, I mean, I didn't really want to move it, but whatever it takes. Can you see? See that indentation there that I showed on the other camera there? That's where this, the edge of this, presses into there, makes an indentation. Can you see the indentation there? I don't know whether the camera can see. And that indentation just below that, that's the 4.5 inch line there. We're looking at the top tape measure, 4.5 inches compression, that's 0. 1, 2, 3, 4 inch compression, 4 1/4, 4.5. See, I had that one where it was 4.5 inches compression before and I marked it. This one is just under that, it's more like 4 3/8. So that would have been 4 1/4, that would have been 4.5, so it's 4 3/8. Is that close enough for you? Anyway, what I'm going to do now, I think, because I'm so fucking cheesed up with this, I want to go to bed. Actually, what I want to do is I want to sit with a beer and watch an episode of Fargo, one of my favourite programmes. Why not? I deserve a fucking treat. I reckon. Been fucking tortured by Gary every fucking day. So put that back there. So what I'm going to do now then, right, I'm just going to steam ahead and I'm going to put another 2 kilogram weights back in there. This fucking useless pile of shit is in my way now. Oh, by the way, if you're wondering why I'm doing it with a cart now, a trolley, instead of the rolling thing, it's because I'm not sure whether he'd want me to mention him, but a certain person mentioned experiments I think it's a he anyway, had been doing, and talking about rotational energy, the rotational aspect being a negative factor in doing these experiments, so that you wanting to eliminate the rotational aspect. So I thought, well, am I making a mistake by having rolling objects, because am I wasting energy in the rotational aspect? Is that why all the experiments we normally see are done with weights on a trolley, so it's just purely translational? I'm never sure if I'm using the right terms because this isn't my area of knowledge. I've only started learning about this since December, when Gary first started talking about it, ripping physics girls' videos to shreds. And at first, when Gary was talking about it, I shared his doubt. It took me a while to think, well, I'm just saying I didn't know the honest truth, and Gary's arguments at first made sense. But then after the 3 months and nobody had tested anything, I thought, well, I just want to see for myself. Let's just see what actually happens in the real world. I don't have that confidence in mathematics. I know I should do, but I don't have that. I'm not intellectual enough. I'm not educated enough in mathematics, so I don't have the skills, the knowledge, the confidence to trust the numbers the way I probably should. So the only way I can do it, I try and make up for my lack of skills in mathematics in other ways by doing practical tests. And that's the reason I thought, well, fuck it, I'm just going to do actual experiments to see what actually happens in the real world. And that's why the experiment at the end of my last video, calling Gary a wanker, the last section where I was talking about his cheating experiment, the red object, I was saying, appears to be going barely any faster than the other object, and therefore, because the other object has twice the mass, it must have more momentum. They don't have equal momentum. Why Gary was insisting that they must have equal momentum, I do not know. And insisting that the red one would have to be going twice as fast, I do not know. It clearly wasn't going twice as fast. You could see that without even measuring anything, but it did look like it was going a little bit faster. And I did actually attempt to measure it with an online stopwatch, but it turned out to be a load of old rubbish, this stopwatch, because when I wasted hours and hours and hours producing a video with all these stopwatch things, and the results were all over the place. And it turns out the reason was, when I slowed the video right down, the online stopwatch was an utter waste of time. It didn't start straight away. Sometimes it was like 1/8 of a second before it started, but you don't notice until you slow the video down and it hasn't even moved, and then the thing's halfway there. So it was a pointless experiment. So I needed some reliable electronics in this case. That's why I've turned to electronics to replicate what Waterloo was doing effectively, with digital displays telling us the actual
times. Anyway, so at least we've got a good system going now with, you know, using the AW4416 as a method of measuring the time. That's lovely and accurate. I'm glad. I should have thought about that before, really. I could apply that to the other experiments. Probably not really worth bothering though, because the other experiments you could verify the velocity using, you know, using these objects, nice copper rotating things. 1 kilogram and half a kilogram. It was just as easy to measure the relative velocity of that versus that by simply watching the audio waveform when it makes a clanging noise when it hits something at the end of the run. And then you measure the blips on the screen. You can see that one took twice as long as that one to reach the second clang. You know, the second clang. You can measure it on the audio waveform. It's very simple. So it's a bit pointless measuring to the millisecond when you can see on a screen they did have the proper relative velocities.
I can see that in those types of audio tests I've done since with these, there was a tiny bit of variation, but it worked both ways. Sometimes this had a bit more momentum, and sometimes this had a little bit more momentum. I kind of presume it averaged out. I've no reason to suppose otherwise, because sometimes it was bob on, sometimes a little bit this way, sometimes a little bit that way. And so I figure, seeing as I was typically doing about 10 runs anyway, I only showed you 1 or 2, I can't remember now. But on the day, I actually did typically about 10 runs and then stop it, put it on the computer and look at it in slow-mo, because that was the only way of me judging what was happening. And so I would never do just 1 run, then say that's it. And as for Gary accusing me of cherry-picking, well, I'll just have to upload the original files where you can see it's one after the other, after the other, after the other. It'll be boring to watch, but that's what I need to upload to clear my name of this false accusation, and I'll do it. Nobody will watch it. Not even Gary will bother. I know, but these are the things you have to do.
These springs are very strong springs. They take a lot of compression. So for this to be compressing up to 4.5 inches, that's a lot of compression really from the 2 kilogram mass at twice the velocity. So let's do its opposite number now. The 4 kilogram mass at half the velocity, same momentum.
Stage 1, a spring compression test 1, heavy and slow, resulting in 3 to 3.25 inches compression every single time. So 4 kilogram double mass weighted trolley over a set distance of 413 millimeters, applying force 1, and that was driven by the intrinsic weight of the push mechanism. Reminded myself to publish a graph displaying all this information on this and the subsequent tests. It's easy to absorb the information from a graph. The average time was 1030 milliseconds. So the lowest was 1005 milliseconds, the highest was 1045 milliseconds. Obviously, I'm showing all this stuff in the wrong order because it's difficult to get organized. So many different videos and files to sort out. So by rights, this should have been at the beginning. But then again, the verification process should have been stage 1, really, shouldn't it? No, in fact, the weighing process should have been stage 1, then the speed verification process, stage 2. There are too many stages to show, and I don't want to bore the shit out of everybody showing them all the boring work that leads up to the interesting bit, which is all anybody really wants to see. Does it compress more or not? And yes, it does. The half-mass object going at twice velocity. Yes, it does compress more. Gary, you do have to explain why that happens, because now I am taking every possible care. And when I do it with air tracks and I get the same result then, and I'm absolutely confident I will, what are you going to say then? You're going to run out of excuses. I think you need to kind of face the reality that there's something you can't explain just using momentum. Like, I'm as baffled as you, but this is nature. I'm just trying to demonstrate what actually happens. I'm not trying to say why it happens. I haven't got a frigging clue. I'm just saying this is what actually happens in reality. Doesn't matter how much you dream what should happen. If something different happens than you say happens or you imagined happens, you've got a problem. You have to face reality. You can't keep dodging it. It's not my fault that nature works this way. I didn't make it happen. In fact, if you disagree with what I'm doing, you do the experiments. They're not that hard. Come on. Just spend a few bob. Look, they're not that hard. Just make the effort. Stop relying on other people. I'm not going to criticize you if you make the effort. Just try and see if you can get the opposite result to me. And I guarantee you won't be able to do it. Unless you did some real serious Darren Brown deliberate trickery, just fake the whole thing. That's the only way you could get the results that you say should happen, Gary. I'm sorry. I genuinely am sorry for you sometimes, because I can see that you're absolutely convinced that you're right, and I'm sorry, but you're wrong. I don't actually like proving you wrong all the time. Only when you annoy the shit out of me, then, yeah. But for fuck's sake, you're winding me up.
So you're making me take pleasure in your downfall. But I don't really want to be like that. I want to share information. I've got so many other interesting things to show you other than this crap. This is boring. Let's get back to the interesting stuff. You know, the electrical stuff and fucking radio. And this is boring as fuck. You think you've latched onto something that you can prove all science wrong, and this is the most startling evidence of them being utterly wrong. And now you're talking about free energy. I feel like you're losing your mind, Gary. There's no fucking free energy. When anytime you think you've spotted free energy, that's time to step back a bit, take a holiday, take a break, and realise that, you know, things are getting out of control. I mean, what next? Are you going to start announcing that you've just realised that a motor and a generator are the same thing? And if you connect a motor and a generator, the generator can feed the motor and the motor can run the generator, and hey presto, you've got free energy, you've got perpetual motion. And no, that doesn't happen. But that's the first thing that most people think when they're about 16. Oh, I've invented perpetual motion. Yeah, connect a motor to a generator and they both run each other. No, they won't. Well, that's the equivalent of whatever it is you're talking about Waterlooing. It's your misunderstanding. The reason you're misunderstanding all this, Gary, is because of your absolute, almost religious devotion to this concept that momentum is energy. I think you need... I understand why. Yes, it makes sense on the face of it, but unfortunately, nature disagrees with both of us. You can't fucking argue with nature. Well, you can, but you make yourself look a tithead. And even I don't want you to look a tithead forever. I would like to get back to something interesting. You denying that water's wet, denying that a pen is a pen, saying it's a pencil because it writes the same, it's the same shape. You being in this fucking constant state of denial isn't that interesting after a while. It isn't that funny after a while either. It's just downright annoying and frustrating and depressing. Now, maybe you know darn well that you're talking shit. Maybe you know it and it doesn't matter to you. All that matters to you, perhaps, is publicity, that you can say the craziest things and you'll stand out from the crowd, and there'll always be 10% of idiots who'll say, ooh, listen to this guy, he's the underdog, let's follow him. And it'd be like the life of fucking Brian, won't it? Oh, look, I've got his slipper, I've got his shoe, Gary's shoe. Do you remember Life of Brian when they found his shoe and they're all fucking worshipping his fucking shoe? You're all different. I'm not. Anyway, let's move on. You gotta have a laugh, ain't you? Let's get on with it, shall we? I'm not even going to bother turning the camera off. I'll just get on and do it. So the way it worked was that weight goes in, plus this hard drive, plus this scrap lead. I trimmed it exactly, so I trimmed it, you know, cut it off with scissors till I got it to exactly the right weight. And a penny. And then that should be exactly 4 kilograms. So now I removed the bottle of water that's hanging on the device. The pushing device, I accidentally cut out the word pushing. It's the pushing device. So I've removed some of the pushing force by taking off the weight that drives it, some of it. It's 6 o'clock in the morning and I'm losing the power of speech. So that was that. Clip that onto the G-clamp. So now... Right. In all honesty, I'm not expecting it to get as far as there again because I do have confidence in the formula. In fact, I need to get this camera as close as I can so you can get a reading. Please don't crash, camera. Please don't crash. You ready? That's probably as close as I'm going to be able to get the camera because the lead is a bit like a banjo string. Are we ready to release the hounds? Right. Well, that wasn't very impressive, was it? Again. Let me get a ballpark idea of how far it was going. I'll put my finger across the 3.5 inch mark so I get an idea. Oh, sorry. I was touching the spring. That wasn't there. Yeah, so it's getting to 3.5 inches. I could feel that. Try 3.75 inches. Oh, I'm measuring off the wrong scale, aren't I? Sorry. No, I couldn't feel it there. Looking on the top scale, the upside down one. 3.25. No, I couldn't feel it there. Try again. No. So it's not getting that far. I'll put it back on 3. Once I've got an idea, once I've got a rough idea, I can use the clay again. So put it back on 3, did it say? Yeah. Yeah, it's getting to at least 3. So I could just cut out all this nonsense and just tell you the results. But you wouldn't trust me. And even when I show you, I don't think Gary's going to trust me. I have an inkling
I have a feeling this is all in vain. It doesn't matter how much. I could do 100 years of effort if I lived that long, and you might still be in denial. I don't know what you can do about that. Maybe I just have to accept that some people live in an imaginary world where they are right all the time, even when the evidence is right in front of them that they are wrong.
I'm going to move the clay from there, smooth it out now. Try that. So it's just creeping over the 3-inch mark, can you see? So I'll record that 3 inches. I'll do a few of these now. Okay, again. I think it's about 3.1 inches. It's not an eighth of an inch. 3.1 inches. I think that's a fair. I'm sorry if you can't see that. Unfortunately, there's not much I can do about that. 3.1 inches. Again, flatten it out again. I don't know if you can see or not. I want you to see. I want you to see what I can see. That's the indentation there where this jabbed into. Oh yeah, you can see that. That's that indentation, yeah. Now put a line straight up there. But then when you line that line up, you can see it's just over the 3 inch mark on the upside down tape measure. Give it another go. I'll leave it as it is, see if it goes any deeper. Yeah, it went a bit deeper then, didn't it? That's gone about. I'll let you have another look again. Can you see? That's gone a little tiny bit deep, hasn't it? If I try and put a mark, or the upper mark at that there, that's in line with it. So I think it now is about 3 1/8. Yeah, that's 3 1/8. Let me just write that down. I'll leave it as it is again. I'm not going to alter the mark. No, it's got no deeper that time, is it? Or is it? Do another one. I'm basically trying to see what's the deepest it'll ever go. What's the deepest it ever goes? So let's do a few. So I've put a mark there. That's gone. Yeah, I can't get the camera in the right place to record it. Call it 3 1/4. That way, you know, there's no argument. It's not worth quibbling over it. I'll call it 3 1/4. 3.25. Let me double check that. I'm confusing myself now. So, sorry, I'm just gonna have to get in the way of the camera. Oh yeah, no, sorry. No, it's a bit less than 3 1/4, but call it 3 1/4 anyway. One more go. And then I'm gonna have a beer and watch Fargo. No different. One more. No different. One more. No different. Okay, so. Right, so 3 o'clock in the morning. 3 o'clock in the morning again. Now, reviewing the results. So, the most it compressed for the fast moving object, the equivalent of the red object in the previous experiment, was 4.5 inches. So we had 4.25, 4.5, 4.5, 4 3/8, 4.3, 4.3, 4.3, 4 3/8. Maximum 4.5. If we go off the maximum that either of them do. Because let's be honest, the velocity was a little bit shy of what it should be. It isn't quite double the velocity, is it? But and then the run with the twice mass, half velocity, so same momentum, which Gary reckons should be bob on equal to the other one. That's only compressed 3 inches, 3.1 inches, 3 1/8 inches, 3 1/4 if I'm being generous. So 3 1/4 if I'm being generous was the maximum so far. So the other one has compressed it more than a full inch more. Total of 1 1/4 inches. Is that right? Yeah, a total of 1 1/4 inches more.
object at twice the velocity has compressed it 1.25 inches more. And for these springs, because these are strong springs, the aviation grade springs, whatever that means, apparently there's something to do with refueling an aircraft. Now, I don't know what the ratio is. I don't know how to evaluate how much more energy that represents, that 1.25 inches. It did more work. How can you deny, Gary, that it just did more work? It compressed those hard to compress springs a lot more. I don't know how you evaluate how much in precise terms. I mean, plus your other claim from the previous runs, that fell foul too. That was wrong too, because Gary's claim that when we use the same force, when we simply halve the mass, it should go twice as fast, didn't happen. Everybody else's claim that it goes 1.4 times faster was far, far closer than anything Gary's said. As far as I can calculate, it's somewhere between 1.27 and 1.3 times faster in these practical demonstrations. I've not managed to get it to actual 1.4, about 1.28 on average. Like I say, it depends which figures you're using, because there is just a tiny margin of error, isn't there? Again, I'm not a laboratory, I'm not a scientist, I'm not pretending to be a scientist. Gary's the one who goes around pretending to be some kind of scientist, or scientist 2.0. Gary's the one who goes around pretending that all scientists since Newton are hopeless, and that there's only him who beats the pants off all of them with his conclusions without doing any experiments at all. He can just rely on the experiments he picks and chooses. He says, I'll have that one, I'll trust that one, I'm not trusting that one. Doesn't matter whether he's seen them or not, doesn't matter whether he can do them or not, he just picks and chooses what suits his crappy argument. There's nothing less scientific than Gary's conclusions. They're all based on pure utter guesswork. Nothing more. No substance to them whatsoever. Absolutely none. Now, even though I've gone through a lot of trouble to try and reach a reasonable conclusion here and in other experiments, he's not going to, I know he's not going to accept the results, because he never ever does. There's not been a single experiment he accepts the results of, except the ones he hasn't seen that suit his purpose. He hasn't seen the ripple tank experiments I did, yet he's willing to cite them, and cite them wrongly. He's willing to exaggerate what I actually did say about my ripple tank experiments. Okay. Room lights, in case that helps at all, I don't know. This is all new territory for me, I've never done this before. Honestly, I would rather eat my own shit than admit that Huygens' principle is correct. but sometimes you kind of just got to bite the bullet a bit, haven't you? And sort of think, oh, I was wrong, But it's too early to say, but it's got me worried. That's what I'm saying. It's got me worried, because you see, the images I've seen so far that have been posted in the past, in all honesty, I've never got to see them until about 3 months ago, when Mickey Farley started posting. Well, he posted one, I think, or two, and I finally got to see either this pattern or something very, very similar to this, and it was the first time I'd seen the water interference pattern, but single slits, water interference pattern, and you're making a pattern like this. I'd never seen it before, and so I must admit, I can't remember whether I sent him, I thought a thank you note or not. At that time, I think I was still brown nosing Gary a bit, if I'm honest. But well, not brown nosing. I wouldn't go that far. But I was. I'm looking at the screen and the camera, but the screen doesn't seem to be picking up the slight waves I can see. But there's no pattern in the waves anyway at this frequency. Yeah, let's open it up again. Back to about 10 millimeters. 10 millimeters. Yeah, so it's at this low frequency, the lowest frequency. So it's at the lowest frequency it will go that we do seem to get this pattern. Barrier. What shall I use? What shall I use? What shall I use? I suppose I can use one of them. Ah, that's not a bad idea. Yeah. I think I've got an idea. So which is that? Right. So I'll cut that. So I'm talking to myself. Where have all the scissors gone? I need them now. Where have my scissors gone? Where the fuck have they gone? Where the fuck have they? All to do is buy this stuff really, but just pay 10 times more for it, as I say. They aren't buying it second hand on eBay, are they? So that's one barrier gone. Oh, so you can see there what happens when you only have one edge. However, I'll replace that edge now with well, it would help. It would help if the wave was starting off looking straight, wouldn't it? And it isn't, is it? That doesn't look straight, does it? In the years. Let me just lower. See if I can get the wave to look straight first of all. You know, before it's not going through anything yet, is it? So I'm just experimenting with the height. This is all new to me. Just trying to get the straightest waves through I can. Okay. Well, that's not too bad, I don't think. That's a very gentle. That's a very gentle wave. So I'll put a barrier there, first of all. Actually, I think I'll put the barrier pretty bit further forward there. In all honesty, you can't see the diffraction around it, can you? I wonder why not. I'll put the other barrier in. It's about 20 millimeters. I don't know why it looks so. I don't know why it looks so shit. And put words in my mouth, claim that I've said something that I haven't said about the ripple tank experiment. I'm happy to back Gary up on his arguments about Huygens, because I disagree with Huygens as well. I'll do 2 or 3 runs again. For me, it looks like it's going somewhere around the 4 inches compression. You see how I put 2 tape measures, one backwards, upside down, because then the backwards upside down one, you can then count off 1, 2, 3, 4. I can count how much compression it's made, can't I?
Stage 1 of spring compression test 1, heavy and slow, resulting in 3 to 3.25 inches compression every single time.
The reason I've not uploaded, or reasons, plural, well, it's because I have so many clips that need showing in a logical order to prevent Gary misrepresenting what I've done by guessing completely wrong right from start to finish. I refuse to let Gary make a mockery of my hard work by releasing data and video footage before I am satisfied I've presented all the information I can the best way I can. The clip you have so far seen was so badly done, just a rough and ready test I did for my own benefit, never really intended for anyone else to see it. That clip wasn't even the best of the various versions I had. I only stuffed it on the end of the video in place of 20 minutes of radar interference experiments, that I realised at the last minute would be a bit too much ground to cover in one video, mixing subjects too much. So in a rush I picked the first one I could find to substitute, and with hindsight I honestly think it was too poorly done and poorly explained. I may let you see some similar ones recorded at the same time, which aren't brilliant either, but at least I verbally explain why I'm doing what I'm doing. Finding these clips when you are in a rush, when you have literally hundreds, possibly 1,000 or 2,000, I've never counted, is very challenging because I do have other things I need to do each day, so finding time is tricky and tiring. My reasoning is based mainly on practical demonstrations rather than me following any theory to the letter, because apart from anything else, as I have already openly admitted, I'm neither a scientist or even someone who has been educated in this particular field. My trade is electrician, and even though I always lack the mathematical skills that most electricians are naturally good at, I always got better exam results than absolutely any of the other 80 or so electrical students, apprentice electricians mainly, who therefore wrongly concluded I must be cheating. Nope, I was just naturally good at the subject from a practical angle, and contrary to popular belief, the mathematics follows that understanding, not the other way around. In fact, I think even Gary himself agrees with this. In fairness, I must point out that that I wish I also had the math skills, because the two do go hand in hand. But in all honesty, I'm so glad I am more practically orientated than intellectual, if you follow me. Apologies, my reply has ended up a rather a mess through trying to rush. I've got to go. Hopefully the experiment in itself, when repeated far more accurately and documented, will make you realise, so we've been tricked into believing something happens which does not, by Gary. I don't always want to hate on Gary. If he lived next door, I would love showing him these demos over a beer or a cup of tea and a vegan biscuit, which I would buy especially for such occasions. I do have some sympathy with the position, but his arrogance winds me up when he is totally unwilling to test things he really should be able to. Sorry, got to go. We'll try to explain better later when I am less rushed. I appreciate your question. If I have not yet answered it convincingly, don't give up. I will try again, but not by merely repeating the same thing. I need to show you what I have.
I'm sorry this has been such a disorganized video. I've got such a lot of information. I don't know where to begin putting it together in a logical sequence without boring the pants off everybody. So I've tried to put the more interesting stuff at the beginning, then I realised, oh, it's backwards now. Anyway, it's information.